Alright, so this is the second video for section 3, catch-up notes. In a separate video, I already took care of those light-dependent reactions, this electron transport. So this video is basically just going to cover that Calvin cycle. So these are my light-independent reactions. They're happening in the stroma of a chloroplast, and I should have everything I need already. So CO2, something that plant just gets directly out of the air, can combine with a 5-carbon molecule to make a 6-carbon molecule. 1 plus 5 is 6. Should be pretty obvious, right? But I also have to take into account that I need 3 carbon dioxides to react with 5 carbon molecules to make 3 5-carbon molecules to make 3 6-carbon molecules. Just because I need to have that many carbons to continue this cycle, right? So I bring in 3 carbon dioxides at a time, combine them with 5 carbon molecules to make 6 carbon molecules. And then the next step is where I'm going to take those 6 carbon molecules, I'm going to break them in half to make 3 carbon molecules. But if my math's correct, 3 times 6, I should have 18 carbons. I need 6 of these 3 carbon molecules to keep everything the same, right? I can't create or destroy carbons, so I have to have them from somewhere. So I need these 6 3 carbon molecules that are high energy, right? They're high energy because they're going to have energy that I captured from before, right? This reaction from 6 to 3, from big to small, may look like it's catabolic, but it's really not, because it's going to be powered by all that ATP and even all that NADPH. Oops. NAD plus is what or DP plus is what I wanted here, that I created in those last set of reactions. So I had this NADPH, right, that had light energy. So I just did that backwards. I'm sorry, guys. Let me fix that real quick. I took, and I'll have to change my color again, NADPH, broke it down to get that NADP plus. But what I was trying to emphasize is there's lots of sunlight energy in this molecule. And there was sunlight energy in this ATP molecule as well. So that energy that I captured in photosystem 2 and photosystem 1, all of that energy is being input in this portion, in this reaction. So that's very much catabolic. Those two reactions are definitely catabolic. So I have to realize that this is actually an anabolic reaction. Just because I went from 6 carbons to 3 carbons doesn't mean that those 3 carbon molecules at the end don't have lots and lots of energy in them. So a lot of things have happened here. A lot of energy got dropped off into these 3 carbon molecules. They are very high energy. So I have to make note that that's definitely an anabolic reaction, because otherwise I might confuse it with a catabolic reaction. At this point, now that I have these high energy 3 carbon molecules, I can take 5 of those 3 carbon molecules, keep them in the cycle, and kick out 1 3 carbon molecule that ultimately I can use to make a glucose. I need to keep these 5 3 carbon molecules over here though, because some way, somehow, I have to restart this cycle. And as you can see, 5 times 3 is 15, 3 times 5 is 15, right? All the carbons I need to remake these original 5 carbon molecules are here in these 3 carbon molecules. Now that process, that reaction, is going to require a special enzyme. That enzyme is called Rubisco. Rubisco helps me take those 3 carbon molecules that admittedly had a lot of energy in them, had energy that I otherwise could use to make glucose, but I had to waste that energy. This reaction, though 3 carbon molecules are smaller than 5 carbon molecules, is actually extremely catabolic, right? I'm losing lots of energy by doing this, lots of captured energy. But I'm still going to want to do this because if I don't recreate those 5 carbon molecules here, then I can't continue this cycle. I can't continue to bring in more carbon dioxide to make more 6 carbon molecules so I can continue this process. So Rubisco is going to be talked about because it's really, really important. It's the only enzyme that we talk about in this section. Essentially, at the end of the day, if it wasn't for the Rubisco, I couldn't do this process over and over again, and I need to do this process at least twice. If you can't use a different color for this 2 times that I put in the middle of this cycle, you should think about making a different style of number, because when I put a 2 right here in front of this 3 carbon molecule, if I at least have a different style of number, that 2 can clearly be different because remember, only one of those 6 3 carbon molecules gets ejected at a time. It takes 2 times through in this cycle. I have to do this whole cycle twice to get the 2 3 carbon molecules that I need to make 1 glucose that has 6 carbons in it. So at the end of the day, Rubisco is a really important enzyme because it allows not only for a plant to do this reaction once, but many, 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 many times, right? Because I'm not just going to do it twice so I can make a glucose, right? I could have made 3 glucose from these 6 3 carbon molecules here from the get-go, but I'm not counting on making 3 glucose either. I want to make millions of glucose. I want to make an unknowable number of glucose that can support not only the plant that this is happening in, but all other organisms that depend on it in its ecosystem, right? Plants make so much sugar that they'll go ahead and just give it to you, right? They'll produce fruit that are sweet that you can eat that give you plenty of energy to do the things that you do day in, day out, right? So it's not only important for that plant that this Rubisco exists, but it's important for you. Without Rubisco, there couldn't be enough energy in ecosystems to support an organism like yourself. So you're supposed to answer plenty of questions about this cycle, but I've pretty much talked about all those things in this video, right? Just follow the carbons, right? Understand that there are 2 reactions in here. First, this anabolic one and this catabolic one that don't quite look like what they actually are. They could be misleading if you went with that big and small and big that we used to talk about. But otherwise, you can use context. If I'm going to drop off energy from ATP, I'm definitely not going to have 3 catabolic reactions happening at the same time. So this C6 to C3 is definitely an anabolic reaction. I need the Rubisco to do this more than once, and I have to do it at least twice to get 1 glucose, but I'm going to do it millions of times, right? So Rubisco is important to keep this going. So that should be good enough for this video.